In this video, we are going to see about synchronous motor. So, we have to recall our DC machine. The DC machine can run as a motor as well as the generator without changing its construction. The only thing, the input will be changed. For a motor, we need to give a electrical energy as an input, and generator we have to give a mechanical energy as an input. That's the only difference, but the construction is going to be same. The same manner, we can have a synchronous alternator that can also be operate as a motor. Only thing, we need to connect an armature winding to a three-phase supply. So then it is called a synchronous motor. The name implies here the synchronous motor because it is runs at the synchronous speed. We know that the synchronous speed n is equal to 120 f by p, and the motor rotation is therefore tied to the frequency of the source. So since the frequency is fixed here, the motor speed is stays constant. That means the frequency, because 120 f by p, so f is the frequency. The frequency for this motor is fixed because we are using the grid frequency. Grid frequency in India is 50 hertz. So the 50 hertz is fixed so that the motor stays at a constant speed irrespective of load or voltages, and it is rotating at the synchronous speed. So that is why we call it as a synchronous speed. Otherwise we can call it as a constant speed operation, constant speed motor also. So see the construction. A synchronous machine is a machine that operates the synchronous speed, we know that. And the motor, we know that it converts electrical energy into mechanical energy, right? So it is a fundamentally an alternator, but we are operating as a motor. So like a alternator, as we discussed in our previous videos, the synchronous motor also has stator and as well as the rotor. So the two main part, stator and rotor. The stator, so which has the three-phase armature winding in their slots, okay, and it receives three-phase power supply. So in alternator we don't give the power supply, we used to take the power supply out. That means the power taken out from the stator. But here we, as a motor, so we need to give the three-phase supply to the stator. And second part is rotor. So rotor is nothing but a rotating part that has a set of salient poles, and this is nothing but a field windings. And also we can notice that the rotor here is a field system, and most of this one has a salient pole excited, and this excitation here is a DC current. So the DC current, when it gets a DC current, that means the winding gets a DC current, it form a alternate N and S poles. Okay, the exciting coil are connected in series with the two slip rings here. So the outer part will have a two slip rings, and the direct current is fed to the winding from the external exciter that is mounted on the shaft. Okay, the stator is wound for the same number. So for example, if the number of poles in the rotor is 4, then the stator also wound for the same number of poles as a rotor poles. So the 4 number of poles will be stator also will be having, and as well as the rotor also will be having. Okay, as in case of induction motor, the number of poles determines the synchronous speed of the motor. Similarly, here the synchronous speed, that means for this motor also the synchronous speed is decided by the formula Ns equal to 120 F by P. So whereas F equal to frequency, P is the number of poles. You can see the construction diagram. Here 4-pole machine is shown, 4-pole rotor and 4-pole stator. the three-phase supply is given to the stator winding, and rotor is a salient pole. So these the rotor windings, that means the field windings, will be placed in the rotor, and the external supply, that means the DC excitation, will be given to this rotor. Few facts about the synchronous motor. A synchronous motor runs at a synchronous speed or not at all. That means the synchronous motor either run at a synchronous speed, otherwise it will not run. So it is the speed constant, that means a constant speed, synchronous speed at all loads, otherwise it will not run at all. So this is the only way to change the speed or alter the speed by the frequency, that means the supply frequency. That is the first fact. Second thing, the machine operates over a wide range of power factors, lagging, unity, or leading power factor, by adjustment of its field excitation. The outstanding characteristics, that means the best characteristics of synchronous motor, is the motor can operate at wide range of power factors. Only thing, to obtain this wide range of power factor, we need to adjust the field excitation. Therefore, a synchronous motor can be made to carry a mechanical load. The mechanical loads may be any pump or any loads, lifts, hoists, whatever it is, at a constant speed. So, with respect to any load, the speed will not change, so it will maintain a constant. And third one, a synchronous motor is not a self starting. The motor is not a self starting. A synchronous motor need an auxiliary things, or auxiliary means that you has to use for the starting purpose, because it's not a self starting. As like a three-phase induction motor, it has to, like a single phase induction motor, we need some auxiliary methods to use the starting of the machine. And the second thing, the machine must be run up to the speed and synchronized with an synchronize. That means like a synchronized operation has to be performed. And fourth one, the synchronous motor are generally of a salient pole type.